Ever notice how you can instantly recognize a friend from a distance? Not by their face, but by how they walk? The way someone leans forward? That little arm swing when they're excited. The unmistakable "that's them" before you even see their face. Now, imagine applying that same uncanny recognition to a buzzing, six-legged insect. Because today we're diving into a question that sounds like science fiction, but absolutely isn't. Can artificial intelligence recognize individual bees just by how they move? Welcome to the strange, fascinating world of behavioral biometrics, where every bee may have its own invisible movement signature, a kind of biological handwriting written in flight. And once you see it, you'll never look at a hive the same way again. Let's start with the core idea. What if a bee has something like a fingerprint? Not on its body, but in its movement. Researchers call this a behavioral signature. In humans, gait analysis is already used in security systems, physical therapy, even criminal investigations. AI doesn't need a face. It looks at rhythm, acceleration, hesitation, consistency. Now scale that idea down to bees. Every bee accelerates slightly differently, turns at slightly different angles, reacts to obstacles with its own timing, lands, lifts off, and hovers in subtly unique ways. To the human eye, bees look chaotic. To AI, they're data-rich. And here's the key point. This doesn't require tags, paint marks, or RFID chips. No glue, no stress, no interference with the hive, just cameras and math. If you've ever studied bees, you know the Waggle dance. It's one of the most elegant communication systems in nature. Direction encoded by angle, distance encoded by duration, urgency encoded by intensity. But here's what's changed in recent research. Scientists aren't just decoding what the dance says anymore. They're looking at how each bee dances differently. Using high-resolution video and AI tracking, researchers have found slight variations in waggle length, timing differences between turns, consistent stylistic patterns unique to individual foragers. Think of it like handwriting. Two people can write the same sentence, but you can still tell who wrote which. By late 2025, multiple studies showed that experienced foragers dance more efficiently, stressed or pesticide-exposed bees show altered movement precision. Individual dance styles remain consistent across days. That means AI can potentially identify who is dancing, how healthy they are, how reliable their information may be. This could fundamentally change how we study foraging efficiency, misinformation within the hive, and decision-making in swarm intelligence, all without ever touching the bees. Now let's move to the front door of the hive. Guard bees don't just react, they evaluate. They inspect incoming bees, respond differently to threats, escalate behavior based on colony stress. Recent behavioral studies suggest guard bees may have unique approach patterns, role-specific flight paths, consistent patrol rhythms. AI models analyzing entrance footage have shown that guard activity changes before visible hive stress appears. Individual guards adjust movement speed during perceived threats. Certain gait disruptions correlate with disease or parasite load. This is huge, because it means behavioral biometrics could become an early warning system. Before mass die-off collapse obvious symptoms, the hive may already be moving differently, and AI sees that long before we do. So how does this work without sci-fi magic? 3 key ingredients. 1. High-speed, high-resolution cameras. These capture wing beat timing, micro-turns, hover, stability flight arcs. 2. Computer vision, AI tracks individual bees frame by frame, extracting velocity vectors, angular momentum, positional consistency. 3. Deep learning neural networks are trained on thousands of hours of movement data. They don't look for a single trait, they learn patterns of patterns. By late 2025, some systems reached identification accuracies previously thought impossible for insects, without marking a single bee. This isn't theoretical, it's happening right now. Okay, cool tech. But why should we care? Because this changes everything about how we protect bees. With individual recognition, we can track pesticide exposure at the bee level, see how climate stress alters foraging behavior, identify which habitats are actually being used, detect disease spread before collapse. Imagine knowing which flowers are truly sustaining your hive, which areas are ecological traps, which bees are compensating for others failing. By early 2026, researchers expect these tools to help guide habitat restoration, inform urban pollinator planning, improve beekeeper intervention timing. This isn't just about understanding bees, it's about giving them a fighting chance. Here's the part that really gets me. For centuries, we've treated bees as interchangeable, workers, units, numbers. But AI is revealing something profound. The hive is a superorganism made of individuals, and those individuals matter. Every bee has a role, a style, a story written in motion. And for the first time in human history, we may finally be able to listen, not by opening the hive, but by watching how it moves. If you enjoyed this deep dive into the hidden intelligence of bees, hit subscribe, share this with a fellow beekeeper or science nerd, and let me know in the comments. Would you trust AI to help manage your hives? Because this is just the beginning. The hive has been talking all along. We're finally learning how to hear it.